Morning. Early Monday morning. Okay, so last I left off with you was the part one of the BGP Confederation, and you were looking at a video, and I'm getting the images up here. Let's see. So you were looking at an image that was like this here, where I had these here starships that I was using as a visual to give a visual of how the Confederation actually looked from a visual standpoint. And just to recap, so what we were doing was I was talking about how the Confederation is built up of smaller autonomous systems like this here. You know, you got these starships which represent BGP speakers, and within these BGP speakers, of course, within this grouping, you have internal BGP speakers. So what that looks like is that internally you have these IBGP speakers, these IBGP speakers, and so on. So you get the picture. And then on top of that, you also get the fact of you can also have a peering between these autonomous systems, you know, within one another here. And all this together is your confederation itself. Like I said, so the confederation is nothing more than breaking up the autonomous system into smaller autonomous systems, or if you want to word it that way, or you could word it, you know, building autonomous systems together into one larger autonomous system. But today what we're going to do is we want to take a look at this on how this looks in the CLI, do a couple things, and we'll go from there. The thing about BGP confederations is that it brings all of your BGP knowledge together. You know, the like I mentioned before, there's three different types of peerings when you think about BGP confederations: your internal, your external, and what you call your, depending on the text you're reading, intra external. So that's basically the sub-autonomous systems that look at another sub-autonomous system within the confederation itself, looks at it as a external BGP neighbor, but it's an intra neighborship when you look at the confederation as a whole. So what we got here is a diagram, quick topology of what I'm going to be talking about and displaying today in the CLI. So what you see here is you'll see routers 1, 2, 3, 4, 5, and you'll see I'm going to be using the layer switch with routing functions on it as well. So you see you have autonomous system 5, which is down here in router 5. And each one of these routers has a loopback, you know, a 50.05, 50, 40.004, 30.003, and 20.001. Those are loopbacks, which will be representing as, you know, interior networks within this IBGP system itself. So you got autonomous system number 5 here, which is indicated by router 5. Now you also have autonomous system 234, which is comprised of IBGP speakers, routers 2, 3, and 4. Okay, clearly 2 different autonomous systems. Okay, autonomous system 5 and autonomous system 234, but together these two sub-autonomous systems together, excuse me, make up the Confederation Autonomous System 5234. And here on the outside world, we got Autonomous System number 1 and Autonomous System 3300. Now, these autonomous system numbers are clearly made up here. You know, these aren't real world autonomous systems. But just to give you an idea, so what we would be concerned with, let's say we are autonomous system number 1. Okay, our organization is autonomous system number 1, and we're concerned with resources in autonomous system 3300. Okay, so you can see autonomous system number 1 has a network. We'll call this a LAN network, which is nothing more than a loopback 10001. And the network down in autonomous system 33 is network 33, 33, 33, 33. Okay, but let's just take a peek inside of this confederation itself, and we'll peek at router number 2. Let me bring router number 2 into here. So when we're looking at this here, we can see router number 2 has an internal network itself of 20.0.0.2. And you see we are actually sitting on what I call a 28 network and a 19 network, which basically the 19 network is connecting us to a eBGP neighbor, okay, autonomous system 1, and the 28 network is connecting us to an iBGP neighbor, okay. So what does that look like? We take a look at the interface brief real quick, and you can see clearly. You'll see the 19 network, which I described, going out to the external BGP speaker, and we have the 28 network, which connects to our internal brother router. All right, and we have our network here that we're going to use as a mock network, our 20.0.0 network. So this is some internal resource for this here confederation itself. Okay, so what we want to do is we want to take a look at how this is put together. So we want to do a show run section BGP. Let's take a look at what we got under the hood here. So what you'll see is, like I described earlier, router number 2 is a part of autonomous system 234. Okay, so what we got here, you'll see the autonomous system. Okay, you'll see we have a clearly defined router ID. Okay, now you know your rules as far as router ID is concerned, so you know this was manually configured, because we definitely have another loopback that's actually has a higher IP address, which it would actually took the ID of that address itself. So we know this here is manually configured. Now here's the things that we got to be vigilant on. Okay, so we know that this router is actually part of a confederation. Okay, and we are identifying this confederation as, like you see up here in the red, 5234, and that's what you see here under this BGP configuration. Now, on top of that, we also have to identify a confederation peer that we have within autonomous system 5234. This is where your sub-autonomous systems comes in at. So if you go back to the topology, you clearly see that autonomous system number 5 is our brother autonomous system, the 234. Okay, so we're telling this router, even though you're in a much larger family, 5234, you also have a brother or sister router here, which is your peer. and that's autonomous system 5. Okay. Now, as far as the peerings itself, if you're familiar with BGP, that's no different. Okay, so you can see we have a peering to router number 1, and we have a peering to router number 3 in autonomous system 234. Okay, that's what makes, as you know, that's what makes that a IBGP peer, having the same and sharing the same autonomous system 234 down here for router 3. And you see we have a process autonomous system up here for 234. And then, like I said, the eBGP is identified with having a different autonomous system. Now, of course, you know the eBGP multi-hop comes into play when we're using loopbacks as interfaces, because one of the things that we know, and let me see if I can remember this command, show BGP, no, is it show IBGP neighbors? Let's go with the neighbor 22222. 33333, because we are on 2. Okay, so let me actually pipe that. That's too much information. Include TTL. Okay, so going back to the whole eBGP multi-hop function. So this here is what you is. Let me wrap this up for you in a nice little basket. So we know the time to live for an eBGP peer, okay, is 255. Now the thing is, when we're dealing with loopbacks, what we want to do, especially when it comes to external, that's what we really want to focus on is external. So on an external router, what you will find, let me see router number 1, and you'll see the difference here. So this is an external speaker, and I'm going to go show IP BGP neighbor, and our neighbor here is going to be 22222. We want to pipe that to see the TTL. Okay. Now here's the thing. By default, let me bring these both up together so you can see them. By default, a TTL on an IBGP speaker is 255. The default on a eBGP speaker is 1. So basically what happens is you get on an external BGP speaker, you get 1 chance to make that connection. That's why when you're reading in your text, you're talking about, you know, BGP speakers need to be directly connected and all that good jazz. This is what they're talking about. It one hop, it's a one-hit wonder and it's done. Now the command that I showed you here before, eBGP multi-hop, that's what allows you to change your TTL. So basically you are giving the TTL a little bit more room to breathe, okay? Because here the thing, we are peering with loopbacks, okay? So like I said, this here, we're updating our source from loopback 0, okay? So the thing is, we know that autonomous system coming from the outside, and we'll do this quick ping of 19.1. All right, we know that we got to go through that physical interface right there. That's 1 hop. That's 1 TTL. That's 1 time to live packet burnt right there. Okay. Now we still got to get to the loopback itself of 222. That's where the eBGP command comes into play at. When you want to connect BGP speakers that are not directly connected, you have to be aware of the hop count. So you're going to have to manipulate that TTL setting on a BGP, an external BGP speaker. So that was enough about that rant right there. So back to what I was getting at. So we got this here internal speaker, router number 2, that sits on the edge of the Confederation itself. So like I was stating earlier, BG, oh yeah, let me do a show run. So like I was saying earlier, we have our peerings, router 1, router 3, which you see here, you know, router 1 being your autonomous system number 1, and router 3 being your internal brother or sister router IBGP speaker. Okay. Now here's the thing. Confederations, you still inherit a lot of the problems when it comes to IBGP speakers. So for example, you have, let me bring up my annotation here. Draw. Let me see what's a good color. I'll go red, no problem. Yeah, I'll go red. All right, so what happens is when in the IBGP world, router number 2 receives an update from router number 1. Okay, business as usual, no problem. Router number 1 says, hey, router number 2, I want to advertise my network of 10,001. Router number 2 says, okay, cool, no problem. I got your information and I got your next hop at 1.1.1.1. Okay, that's the autonomous system next hop out to this here external. That's the autonomous system next hop for autonomous system number 1. Now router number 2 says, now here's where the problem comes in. Router number 2 takes all that information and it passes it on to its brother router or its sister router, the other autonomous internal speaker, number 3. Now what happens here is that router number 2 says, hey, router number 3, let me tell you about this information that I got. Let me tell you about this here eBGP speaker I know about out in autonomous system number 1. Okay, he has a network of 10.0.0.1. And, you know, I'm going to get to him on the next hop of 1.1.1.1. Now he passes all that information on to router number 3. Okay, so one of the first things that we realize that we are broke on is the fact of router number 3 now thinks that the next hop is straight over here to router number 1. So the next hop stays the same. Okay, but that can create a problem for us because router number 3 basically is being told to get out here to this 10.0.0.1 network, just go straight to router number 1. That's what it thinks this next hop is. Okay, and if you would look at his table would actually say that. His table would say next hop to get to that 10, to get to that autonomous system number 1, it's going to be 10.0.0.1. It's like it's almost like saying, you know, let's not even worry about router number 2. I'm not even trying to send anything to router number 2. I'm going to send it straight on. I'm just going to skip and bypass the middleman and go straight to router number 1. That's a problem in itself. So you learn that in the IBGP environment, to get over that hurdle, you have to use a command where router number 2 tells router number 3, okay, is iBGP speaker, hey, if you want to get to autonomous system number 1, this external speaker, what I want you to do is I want you to send your traffic to me, okay? I want you to send your traffic to me. And this is done through what is known as the next hop command, okay? So let me bring up router number 3 and show you what that actually looks like. Let me get rid of these annotations. Hold on a second. So router number 3, when we look at show run section BGP, what we can see is no, that's not the command I'm looking for. I'm looking for router number 2, which tells, there we go. Router number 2 tells its neighbor, router number 3, it says next hop self. So back to what I was saying, router number 2 tells router number 3, hey, if you want to get out here to this autonomous system, I am the one you need to be sending that traffic to. So 3 sends any information, any packets that it needs to get to autonomous system number 1, its external speaker, send it to number 2. Now, here's another inherited problem that we have to deal with. Back when I was saying earlier that autonomous systems, internal autonomous system, router number 2 tells router number 3 all this good information about this autonomous system that it knows about. Now, here's the rule. This is one of BGP's loop prevention rules. Autonomous system 234, this iBGP environment, router number 3 that has learned this update about 10.0.0.1 from router number 2, since it has learned that information from router number 2, an internal speaker, it cannot, it will not propagate that information to router number 4. Okay, that's not going to happen because the designers, basically what they did was to prevent any loops from happening. They the rule is if an iBGP speaker learns of routes, prefixes, and all the other good information from another internal speaker, it cannot forward it to another speaker in itself that it's connected to. So what does that mean? That means that router number 4 is out here in the code about this here 10.0.0.1 network. Okay, so there's a way that they talked about that you'll read about and you'll see as far as how to get over this hump when it comes to iBGP. Now, a couple things can happen. Router number 2 can actually, you can do a full mesh where router number 2 is peered to router number 3 and is peered to router number 4. Now, let me get some water here. The thing is, in a small environment like you see here on this here topology, that's actually doable. But in real world, where you have hundreds of routers, that means you got to have that many more connections. And then you add one more router and you got to have that many more connections. So you can see where that can become problematic. Uh, the other way of getting this, which you'll read about, which is not really advised, is allowing your your BGP routes to be leaked into your interior gateway. Okay, so your interior gateway protocol needs to know about, these here external routes out here. Now, BGP handling all those routes is not a big problem in the real world. In the lab environment, it's no big deal. But in the real world, that you're not going to have too many situations like that. You're not going to have situations like that where you're pretty much opening the floodgates for your BGP routes and everything that's out there to come into your environment. That's just too much for your interior gateway protocols. So since we know that, what we utilize is something known as route reflectors. So this is the one time that we probably break the loop prevention rules. So what we do is we actually make what's known as a cluster, and the route reflector cluster is nothing more than a server and a client that it serves. Okay, and that cluster will be identified by that given router ID's number. So what happens in turn, what happens is router 3 will become a route reflector, okay, for its client, router 4. So what happens in essence, 2 propagates information from number 1 to 3. Now, general defaulted rules, 3 cannot re-advertise what it learned from its internal neighbor speaker to 4. That's where route reflectors come into play at. Route reflectors will then propagate that information from router 2 that it learned about router 1, this autonomous system number 1 out here. Okay, so then what happens is router 4 now learns about the information about autonomous system number 1, and it can then propagate down to router 5. Okay, so the thing is, route reflectors breaks the rule, but at the same time, it doesn't break the rule, because see, here's what happened. We know that, let's just say if, let me delete these here drawings. Now, you sit there and you say to us, you sit here and say to yourself, why do we have a rule and then we're going to literally put something in place to break that rule? Well, let's just say in the event, we had router number 2 that was connected to router number 5. Okay. Now that, you can literally see that'll be a loop right here, so the thing basically is if 4 propagates to 5, okay, and then 5 turns around and repropagates that same information to number 2 will actually say, whoa, let me look at this here update. Wait a minute, I see myself in it. Okay, this is basically, this information originated from me. So once router 2 was to see that, it would recognize that as a loop and would pretty much discard that packet. So, but like I said, that's what route reflectors do. And at the same time, we have to look at this from the standpoint coming from autonomous system 33 down here. Okay, so autonomous system 5 learns about this external network down here, 33, 33, 33. Okay, it sends it to its brother router right here, number 4. All right, through a Confederation intra connection. Okay, and 4 turns around and says, okay, I now know about autonomous system 3300 and its network 33.33. It learned that from an internal speaker, number 5. But guess what? It cannot send it to number 3. So therefore, number 3 is left in the cold about the information on 33, 33, 33. So again, what happens is router number 4 has to become a route reflector to propagate those routes learned from that external system to keep that end of the network from being in the code about autonomous system 3300. Okay, so what we look at, let me bring up number 4. And what you will see, let me see, clear all drawings. There we go. What you will see is show, run, include, do a section, BGP, there we go. Okay, so you will see neighbor 333, okay, is a route reflector client, So therefore, it will receive those routes from number 5, okay, and then it will actually propagate those routes to router number 3 here. And then 3 will know about the 3300 network, the 3300 autonomous system, and it will send that information to 2 as well. And that way 2 will know about it. Okay. And as you see up here, like I was explaining earlier with router number 2, all right, we have a Confederation identifier of 5234, and we also know that we have a peer in that Confederation, which is autonomous system number 5, or as they call sub-autonomous system number 5. Now, like I said, if you look at number 5, you'll see something the same. You'll see the same thing, except instead of it being autonomous system 5, you'll see autonomous system 234 as its peer. So sub-autonomous system 234, okay, which consists of routers 2, 3, and 4. And you also see the actual Confederation identifier itself. Okay. Now the thing is, let's take a look at autonomous system 3300. Let me bring this over here. All right. And show IP BGP summary, begin neighbor. So tell me about the neighbors here we got. All right. So what we see, we're here at autonomous system 3300. Okay. And we call this is the 12 net. All right. Now what we see is that our neighbor is here at 12.0.1.205. And what you see here, we're at 254. And we can confirm that. Show IP interface brief, pipe, include 1.254. And you'll see that's what our interface there. Okay. And the other thing I wanted to point out, now the autonomous system, the external autonomous systems do not know the inner workings of a confederation. It doesn't really care. And why I say that is for the reason you clearly see we have autonomous systems 5 and we got autonomous systems 234. Now, autonomous system 3300, which is this one, is connected to sub-autonomous system 5, okay, which Intel is connected to sub-autonomous system 234. But an external BGP neighbor don't give two flies about that. It looks at it as one big autonomous system, 5234, okay? And you'll see this here is receiving 11 prefixes, but that's I'm gonna show you where that's a problem at later on, because this actually goes back into show IP BGP, all these routes here, okay? Now this is basically this is kind of synonymous of BGP coming through into your autonomous system, which is a no-no. So there's no reason why autonomous system 3300 needs to know about router 1, 2, 3, 4, 5, the internal networks that those internal routers are using that are all within this here confederation. This IBGP environment is really just a transit autonomous system. Autonomous system 3300 is more concerned about the resources in autonomous system 1. That's all it really needs to know about. So having all of these networks in the lab environment, it's no big deal. But just imagine one of these networks that I'm highlighting here represents 50,000 routes in the BGP world. You can see how that can become overwhelming, okay? What you want to see is something that looks like, let's go and take a peek at autonomous system number 1. And this is what ideally you want to see. This is ideally what you want to see. So autonomous system number 1 only cares about really 2 networks. You got its network land, whatever you want to call it, that it advertises to 10.0.0.1, which is depicted on this here topology here for autonomous system number 1, and is also interested in the actual resource down in autonomous system 3300. Okay, you can clearly see the difference between these 2 routers. One is more ideal and one is not. Okay, and clearly you can see that this one is not ideal. You're letting entirely too much stuff in. This is the gates being opened up, the floodgates being opened up on BGP for BGP to be, running rampant within your autonomous system. This one here, not so much. The difference, so let me do this. See if this will actually come up and show. So I think I got certain debugs turned on. So let me just do this. Let me clear the BGP session here on this here. That's a destructive. Okay, let me do this. Let me show you debug IP BGP updates. Okay, so let me do this one more time, and you'll see what happens. And this is what'll happen in your organization as well. All right, so let me stop this here. Now let's take a look at this. Now BGP, you can see that BGP is up. Okay, autonomous system number 1 is up with the autonomous system 234, or I should say router 1 is up with neighbor router 2. But as you see here, as we receive these updates, okay, we're denying information coming from iBGP. We're denying information coming from router 2, router 3, router 4. You can see we're rejecting their internal networks, okay, all coming from 5234. Like I said, the outside world, all it sees is 254. 5234. Okay, it sees the Confederation as a whole, not the individual autonomous system that these networks come from. You see, we also rejecting router number 5. Okay, but here's the thing here, check this out. We received this here update 333333. Like I said earlier, that's what we're interested in. Okay, that's the resource we're interested in. So now what the router does, it installs the route for 3333 that it actually learned from router 2. Okay, and router 2 got that information from basically router number 5. Okay, they learned it from autonomous system 3300. It pushed it to 4. 4 turned around and said, okay, I'm going to follow the iBGP rules and I can't send this to 3, but the system engineer made me a route reflector. So therefore, I'm going to go ahead and break that rule, push it to 3, and 3 turns around and pushes it to 2. Okay, so that's how the 3333 network got all the way around through the Confederation to get to number 2. So that number 1, autonomous system number 1, knows about it. And as you see, it installs that into the route, which gives us this much cleaner routing table for BGP. So 3333 originated from autonomous system. That's the path right there. Autonomous system 3300, in essence, comes through autonomous system 5234. Like I said, an external BGP speaker doesn't care about those sub-autonomous systems. The only time you'll see the sub-autonomous systems is when you're actually looking at a BGP speaker internally. So for example, let's do this. Show IP BGP. Let's say we want to learn 50.0.0.5. Let's see what comes up there. Okay, so here you'll see that we know this here route was learned from 3. Okay, but we also know that 4 was a route reflector. Okay, that's what you can see, and you can see this here when you start seeing the cluster in that routing table information, that cluster list. That's how you know there's a route reflector that's involved. Okay, now this here is a Confederation internal. All right, now here's the thing. Let me show you this. See this here, autonomous system 5. Now we know that's where the network is that we're using that loop back. So that's that internal network for that router. But just keep this here number 5 in your mind real quick. So show IP BGP. And what you'll see, we can cut it right here. What you'll see is number 2 learns about the 33 network. So we got some identifiers here. We got the I, which represents, it learned it from a BGP, an internal BGP speaker. Okay. We got the little greater than sign. All right. We know that that's the best path. And of course, you know, we got the asterisk that basically tells us, okay, yeah, that's a valid path. You know, that's legit. But here, what we're talking about, we know this comes from autonomous system 3300. Now, remember when I told you external BGP speakers don't care about all the sub-autonomous systems? It just looks at it as one main, as one main system that it's connected to, 5234. It looks at it as a confederation as a whole. The internal speakers will actually break it down, and they will be identified with the parentheses in the path. So that's how you can tell the difference there. Normally, when you look at BGP tables in everyday environments, there's no parentheses. It's just the autonomous system, you know, with the autonomous system, with the autonomous system, this, that, and the other. When you see those parentheses there, you know that it's in it's within a confederation. So let's take, for example, let's take one out of one of the other internal speakers out of, let's say, let me see if I can do this. Show IP BGP. No, let me see. Let me come to number 3. Go to number 5. So here, you see that number 5, which is an autonomous system 5, receives its updates from autonomous system 234. Okay, so like I said, the internal speakers to each other, they can actually break down within the confederation which sub-autonomous system it actually comes from. There you see 5, here you see 234 is identifying its brother as 5, and autonomous 5 is identifying its internal brother at 234. But the external speakers, okay, recognize the confederation as a whole, doesn't look at it as those sub numbers. So, yeah, here you go, right here. All those routes coming from the Confederation 5234 as a whole. So you won't see it broken down into the actual sub-autonomous systems themselves. So this is just a quick, well, not a quick, because ain't nothing about BGP quick in my opinion. So this was a rundown and a high level one. This really wasn't that much into detail, but this was just a rundown of confederations, and there's a lot more that I actually haven't really talked about. But just to give you an idea on confederations at the CLI level, on what this looks like and how you got to put it together. So until next time, that's part 2 of my BGP confederations explanation, and I'll talk with you again.